Hello everyone. Today we are going to talk about logarithmic functions. What are logarithmic functions? Let's return back to exponential functions first. Remember we had functions f of x looking like 2 to the power of x. And if we graph this function, it's going to look like this. That's a graph, right? Now guys, if I check this function with horizontal line test, I'm going to see that the function intersects horizontal line only once everywhere. So it's 1 to 1. And when function is 1 to 1, means that it has an inverse f inverse. And we have a notation for this inverse function. It's not like going to be 2 to the power of x. It's not going to be 2 to the power of let me write it down so you kind of understand it a little bit better. 2 to the power of x inverse, because this way it looks very much like it's 2 to the power of x to the power of -1. No, we're not going to use this notation. We're going to introduce a new notation. It's going to be inverse function is going to be called log with base 2 of x. So here, 2 shows what was the base of exponential function. Okay, and how this inverse function is going to work. Well, for example, we have 2 to the power of x equals 8, which means that x equals 3, right? And it's actually 2 to the power of 3 equals 8. Now, if somebody, remember that, I'm going to graph again. Remember that direct function f connects x and y in this direction, and inverse function takes y and brings you back to x. That's inverse function. Y here is y, 8, right? So we're going to take inverse function with base 2 of 8 and supposed to get back x. What was my x here? It was 3, right? Because 2 to the power of 3 was x. So this is the power, and this is a number, and this is a base. So basically logarithm with base 2 of 8 shows to which power you need to raise 2 to get 8. That's it. Very simple definition. We are going to consider base of logarithms be greater than 0 and also not equal to 1, like exponential function, right? How the graph of the logarithm is going to look. Remember that the graph of inverse function is going to be a reflection of the graph of direct function around the line y equals x. Well, let's do this reflection. For example, this point is going to be reflected here, and this point is going to be reflected here, and this horizontal asymptote is going to be reflected into a vertical asymptote, and my graph is going to look like this, and that's a graph of log with base 2 of x, kind of a reflection. Okay, so what is the difference between logarithmic function and exponential? Okay, so let's look at the red graph now. What first? Domain. We see that there are no values for negative x's here, right? So we're going to say that domain is x belongs 0 to positive infinity. Just look at the picture, because that's an asymptote and nothing comes over there, right? Second, when x goes to infinity here, where y goes? Y goes also to infinity, right? And when x goes to 0, over here, right? X goes to 0, this is 0. Y will go to negative infinity. Line x equals 0 is going to be called vertical. Sorry, my pen is not obeying me. Vertical asymptote. And that's how logarithmic function is going to look. Now, guys, we have two, like besides all normal logarithms with base 2 or 3 or 5, we also have two special logarithms. The first one is called common logarithm. What is common logarithm? By definition, guys, logarithm with base 10 of x is written as just log without base of x, or even in some calculators, it's written like lg of x. This is called common logarithms. Why people are using common logarithm? Well, let's try to find what is common logarithm of 100. Well, which means that to which power we'll need to raise 10 to get 100? Well, to the power of 2. Basically, logarithm is very easy to calculate if you have a round number here, right? And just how many zeros we have. For example, logarithm of 1000, common logarithm of 1000 is going to be what? 3. Well, actually, it shows how many zeros your 1000 or 100 has, right? The graph of common logarithm is same as like logarithm of 2 to the power of x, so I'm not going to graph it, but I want to discuss a couple of like interesting cases with common logarithm. So for example, what is common logarithm of 0.1? To which power we need raise 10 to get 0.1? Well, actually, maybe this one is 1 over 10, right? To get 0.1, because 0.1 is 1 over 10. So the power here is 10 to the negative 1, and we are going to get a negative power. So x is going to be negative here. Remember, if your numbers are small, the values of logarithm are going to be negative. If you look at the graph, it's kind of obvious. Like for numbers which are greater than 1, the values of logarithm are positive. Numbers are less than 1, like 0.1. Numbers are negative here. Values are negative here. Okay. So what other special logarithm we have? We have natural logarithm. Natural logarithm is another interesting logarithm. The base is e, the base of natural logarithms. People are writing down as ln of x, and there is no second notation. Well, for example, ln of e is to which power we'll need to raise e to get e? Well, x equals to 1, so we're going to write down 1 over here. Ln of e square. To which power we'll need to raise e to get e square? Well, obviously, the power is 2, right? Okay. What else? I don't know. Maybe something a little bit more complicated. How about ln of 1 over e? To which power we'll need to raise e to get 1 over e? Well, you know that 1 over e, it's actually e to the negative 1. So comparing the powers, we find out that x is equal to negative 1. Okay. That's all about definitions of logarithmic functions. We are going to talk about properties of logarithms in the next section. I don't know like why in the book they divided it into two sections. I'm going to graph both natural and common logarithm on one graph. And well, again, just to do a comparison. So I'm going to start with a natural logarithm. That's going to be 1 here, right? Vertical asymptote. And then if you go back over here, you see that, for example, I'm just going to do this here. Then log of 10 equals 1, right? Because like to which power we need to raise 10 to get 10? It's 1, right? Log of 10 is equal to 1. So if you plug in 10 here, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then you are going to get 1. And the graph is going to look like this. Okay. So this is log of x. Now I'm going to graph exponential function. Exponential function ln of e equals 1, right? So e is approximately like 3. On my graph, it's going to happen somewhere a little bit less than 3, equals to 1. It will go through this point again and be equal to 1. So this one, e to the ln of x is a little bit higher. Okay. Okay. Well, that's very good. And I think we are going to talk about properties in the next section. A short section.